So here is the problem. This is power series representation of this function. This is natural log of 5 minus x. Until now, we've been using 1 by 1 minus x to write series, which is n from 0 to infinity of xn, which is geometric series, when converges when absolute value of x is less than 1. But this is nothing like that, right? So hear me out. I'm going to start by considering 1 by 5 minus x. I know it's not exactly the same function, but how will you expand this? This would be equal to, I can factor out 5 from the denominator, 1 minus x by 5. Now, this portion, I know I can expand using our original function. Leaving 1 by 5 outside, this would be n from 0 to infinity x by 5 power n, okay, using our trick which we have been using until now. But now, if I write it one more time, I have 1 by 5 minus x is equal to 1 by 5 summation n from 0 to infinity x the power n by 5 the power n. What if I integrate both sides with respect to x? Okay. Now, on the left-hand side, the integral is natural log of 5 minus x with a negative sign because x coefficient is negative. On the right-hand side, what we have? Now, it seems like a difficult thing to integrate a series, but you know what's happening is that this is just sum of the terms. It's not anything complicated, right? If you understand it, this thing should just look like 1 plus x by 5 plus x squared by 5 square and so on. So basically, we are just integrating each term separately, right? So it's going to look like 1 by 5 integral of this 5 by 5 power n is just constant because we are integrating with respect to x. The variable is x for the integral. So when I integrate, summation is gonna stay, and the inside, what is the integral of x the power n? X the power n plus 1 divided by n plus 1, but 5 the power n will stay, plus some c. Okay. Now this negative sign can go on the other side. If you multiply both sides by a negative sign, then natural log of 5 minus x can be written as negative 1 by 5 summation n from 0 to infinity x the power n plus 1 divided by 5 the power n times n plus 1. Now I should write negative c, but the c is just constant, so negative c is another constant, so it will be just adjusted inside the c only, right? So if you feel like you can write it c, a different c also, but it's just a constant. Let's multiply 1 by 5 inside, negative sigma n from 0 to infinity x the power n plus 1 divided by 5 the power n times 5 should be 5 the power n plus 1 times n plus 1 plus c. Okay. Now you guys notice everywhere the index we are using is n plus 1, but n is starting from 0. So we can adjust that because all n values are starting from n plus 1. So we can say natural log of 5 minus x is equal to negative n from 1 to infinity. You guys notice in place of 0, I changed it 1, and I can replace our powers by n. So we were starting from n equal to 1 now, plus c. Our question was find the power series representation of this function, which we did. The only problem is we do not know what c is. For finding c, I'm going to use a trick. I'm going to put x is equal to 0 on both sides. So what will be on the left hand side? Natural log of 5 minus 0, natural log of 5 equal to negative. Whenever I put 0 in place of x, everything will become 0, right? So this whole thing is going to just become 0 when I put in place of x 0 plus c. So what did we get? C is equal to natural log of 5. So that means our final answer can be written as, from here we can say the goal was to write power series representation of this is negative n from 1 to infinity x the power n divided by n times 5 power n plus natural log of 5. So our solution final is this. Remember, all this was possible if x by 5, we started with x by 5, is less than 1 in absolute value, meaning absolute value of x is less than 5. Therefore, radius of convergence is 5 and interval of convergence is negative 5 to 5.